Okay, going over the quiz review that you guys had for homework. Please make sure you are checking on how you solve these. I'm going to write down the formulas so you know them as well. So the first three questions, you should have used the formula for arc length. So please pay attention to how this one is written. It is arc length equals the measure of the arc over 360 times circumference. Keep in mind circumference can be represented as C. It could be represented as pi times diameter. It could also be represented as 2 pi r. Okay, so that's for arc length. So looking at this first one, keep in mind this is not the measure of my arc. The measure of your arc is in degrees. This is not degrees. That means this is the length of my arc. Okay, that's my arc length. So for this one, what formula am I using? For this one, I'm using the arc length equals the measure of the arc. Pay attention to what they're giving me. Because they're giving me my radius, I'm going to use 2 pi r. If you use diameter, that's fine. You just have to make sure it's pi times diameter and you're doubling the radius. So you could have done 14 pi, which was also fine. All right, so solving this, looking at what I have, plugging in what I have, my length is 13.7 equals, I don't know the measure of my arc over 360, times 2 pi times my radius, which is 7. Okay, this is how I'm going to solve it. As long as you have that setup or something like that, that's fine. We could have, again, solved multiple different ways. I'm going to solve it as 13.7 equals 2 times 7 times pi x. Multiplication, it doesn't matter what order you multiply in as long as you're multiplying the correct numbers. And I'm dividing it by 360. I'm then going to multiply 2 times 7 times pi. I'm going to get 43.982x divided by 360. And keep in mind that still equals 13.7. I'm then going to multiply both sides by 360. If I multiply both sides by 360, I'm going to get 4,932 equals 43.982x. And then I'm just dividing, which is my last step. Again, we could have solved it different ways. This is just how I solved it. If you divide it correctly, and if we rounded correctly, x is going to equal 112.14 degrees, because that is my measure. Any questions on number 1? Again, we could have solved it different ways. A lot of students solved it a different way than I did, but as long as we're getting to the same answer, you're fine. All right, looking at number 2, arc length. This one's asking for the arc length, so I'm solving for what my formula is. So for this one, I'm going to use length equals the measure of the arc over 360. All right, once I did that, I'm still using 2 pi r because they're giving me my radius. Again, if you used pi times diameter, you have to just make sure you double the radius to give you 8. Solving for what I have. I am solving for my length, so all I'm doing is setting up the measure of my arc, which is also 83 over 360 times 2 pi times 4. Okay, same thing. How I want to solve it, I'm going to have 83 times 2 times 4 times pi over 360. This one's pretty easy. You could just plug it into the calculator, multiply everything, divide by 360, and my answer is going to be 5.79 for my arc length. Any questions on 2? All right, let's go ahead and go to 3. Solving for my circumference. For this one, I'm using the formula with the C for my circumference. So for this one, the formula I'm using is length equals the measure of my arc. Again, that has to be in degrees, over 360 times circumference, and that's what I'm solving for. So plugging in what I have, my length is 8, because that's in units. The measure of my arc is 48, dividing it by 360, and I'm solving for my C. How am I solving for my C? I'm going to multiply both sides by 360 to get rid of it. If I multiply it, I'm going to get 2,880 equals 48C. Divide by 48. And my circumference is 60. And that's my answer for 3. All right, any questions on the first 3? Okay, again, you have to know the formulas for those in order for you to solve. All right, looking at number 4. 4 asks for 2 things. They want me to convert degrees to radians and radians to degrees. So for that, I'm going to go ahead and write my formulas. Again, you have to know the difference between these two. If I'm going from diameter to radians, okay, I'm going to solve it as degrees, whatever degrees they're giving me, times pi over 180. Keep in mind for your answer for radians, it has to be in terms of pi. So you need to leave pi, you do not evaluate it. Looking at the next one, I have radians to degrees. And for this, it's going to be radians times 180 over pi. That's something that you guys are going to have to remember. So first thing they asked me for, convert 26 degrees to radians. Pay attention to how I'm solving this. Degrees to radians. I'm going to take my degrees, which was 26, times pi over 180. I'm just going to change it to 26 over 1 and multiply across. 26 pi over 180. You can cross simplify for this one. Your answer is going to end up being 13 pi over 90, and that's my answer for the first one. That's me converting my degrees to radians for the first part. Now I'm going to go ahead and convert radians to degrees. Okay, I'm going to have 5 pi over 9 times 180 over pi. Okay, looking at this one, I'm going to cross simplify. Please make sure you're cross simplifying correctly. My pi's are going to cancel out. It's just going to give me 1. And then I know I could cross simplify 9 and 180. 9 goes into 9 once. 9 goes into 180 20 times. I'm going to end up with 5 times 20. And my answer for this is going to be 100 degrees. Okay, questions on number 4. Questions on number 4. All right, looking at 5 and 6. 5 and 6 are asking for the area of the sector. So for this one, again, you have to know the formula. Please pay attention to the difference between area of the sector and the length. The length is only asking about, let me go ahead and highlight it. The length is only asking about, let's consider it your pizza crust. It's just that piece. But the area of the sector is asking for the entire thing, not just the crust. So I'm using the formula for area, while the length is using the formula for the circumference, which is just the outside. So hopefully we understand that a little bit more. So for this one, area, sector area, okay? Formula for this is I'm still using the measure of the arc over 360. This is times your area of the circle. And area of the circle also equals pi r squared. Okay, so it can either be a or pi r squared, depends on what they're giving you. So with that being said, looking at this question, it says they want the sector area of the red section. Okay, find the area of the red sector. So using my formula, using what I know, they're giving me my radius, so instead of using my area, I have to use the formula for area. So I'm going to have 100 over 360 times pi 12 squared, pi r squared. I'm going to change it to putting it over 1 and I'm going to multiply across. Multiply across, I'm going to have 100 times 144 times pi over 360. And then that's pretty easy. You could just plug it into your calculator. If you plugged it in correctly, it's going to be 125.66 for my answer. Looking at the next one, I have to solve for my blue area. Okay, I have to find my blue sector. So in order for me to find the measure of the arc, I'm going to go ahead and I'm going to do subtract what I used. 100 minus 360, or let me write it the correct way. 360 minus 100 is going to give me 260. So that's what I'm using for the measure of this arc, 260. So setting it up, I'm going to have 260 over 360 times, I'm still using pi 12 squared. 12 was my radius, and I'm putting it over 1 again. Yes, you could simplify before you multiply. It's up to you. But I'm just going to go ahead and bring everything else across. 260 times 144 times pi over 360. If you solved it correctly, it should be 326.73. So you have to remember your formulas. All right, looking at 7, 8, and 9, you're using the diagram to the side over here. So looking at this, identifying specific information. Going ahead and identifying my center, which is this point right here. Looking at my center is C. Going ahead and finding my radius, looking at my radius. My radius is either this point or this point. So my radius is either segment CY or RC. Again, you could flip those. Looking at the next one, I have my apothem. My apothem is this segment right here. And my apothem is CZ, or you could put ZC, that's fine. The next point is my central angle. Keep in mind, central angle is this point right here, from here to here. That's my central angle. And my central angle is an angle, so it's angle RCY. Or yes, you could flip it over and write it as angle YRC. So that's my important information for this one. All right, looking at the next question, they want me to find the measures. So I'm going to have to give them a numeric value. So looking at the first one, finding the measure of RCY. How would I find that? I'm going to take 360 divided by the number of sides. Okay, 360 divided by the number of sides, which is still this pink little line right here. If you divided correctly, your answer should have been 45. I have an octagon. Octagon has 8 sides, so if you divide it, you're going to get 45 degrees. Looking at the next one, the measure of angle RCZ. RCZ is right here. Finding that measure, I have to divide 45 in half. If you divide it correctly, it's going to be 22.5 degrees. And then the last one is finding the measure of ZRC. So finding ZRC, I'm going to have, let me get my highlighter. ZRC is the remaining angle right here, so I have to subtract 22.5 from 90. If you subtracted correctly, your answer for this should have been 67.5 degrees. All right, going ahead, it says the radius of the circle is 8 units. Find the area of the octagon. Formula for area of an octagon or area of a polygon, a regular polygon, is your area equals ANS divided by 2. Your apothem times the number of sides times your side. So let's go ahead and find information we need. Keep in mind it's an octagon. Do I know how many sides are in an octagon? Yes, I do. I have 8 sides. Do I know the side measure? No, I don't. Do I know my apothem? Again, no, I don't. So that's what I have to solve for. So looking at this diagram, we know that this angle right here, we said is 45 degrees. I know that I have a right angle, and I know that my radius is 8, because that's what they told me. So I have to solve for 2 things. I have to solve for my apothem, which is this line right here in orange, and I have to solve for my side, which is my line here in green. So I'm going to go ahead and redraw it because I know I can solve for a right triangle. So here's my right triangle as best as I can draw it. Here's my right angle. They gave me my 8 here, and I'm cutting that 45 in half, which is going to give me 22.5. I have to solve for 2 things. I have to solve for, technically this is my opposite side, okay, because I'm going to go ahead and use SOHCAHTOA. I'm going to use my trig ratios to solve, because I can't use special right triangles, I can't use Pythagorean theorem, so I'm going to have to use my SOHCAHTOA. So I have my opposite and my adjacent, which is also considered my apothem. This is my apothem. This is my side, which is considered my opposite right now. So looking at it, looking at what they're giving me, I'm going to go ahead and use SOHCAHTOA. And solving what I have to solve for first. Looking at it. Going ahead and solving for, let's do my apothem. Okay, my apothem's right here. I have my hypotenuse. I'm solving for my apothem. I'm going to go ahead and use my cosine. So solving for this one, I'm going to use cosine. 22.5 equals adjacent over hypotenuse, which is 8. I'm then going to go ahead and multiply both sides by 8. Multiplying. All right, we'll round our answer to the nearest tenths. So I'm going to give 3 digits, so I round at the very end. So for this one, my apothem is going to be 7.391. Okay, because I'm going to round at the very end. So 7.391. Going ahead and solving for my opposite side. So here's my opposite side. I'm solving for my O given my H, so I'm going to use sine. So solving, I'm going to go ahead and have sine 22.5 equals opposite over hypotenuse. And again, I'm still multiplying both sides by 8. So 8 sine 22.5, rounding to the nearest thousandths. I'm going to get for my opposite side 3.061. 3.061. Keep in mind that's only for one side. 3.061. I need to double it. 3.061. I need to add it twice or multiply it by 2. So I'm going to go ahead and I'm going to go right here and multiply it times 2. Just do that on my calculator. I'm going to get 6.123. I'll just round it. I just did it on my calculator. All right, so that now is for my side. 6.123. And plugging it into my formula to solve for my area. So plugging it in, I'm going to have 8 times 6.123 times 7.391, all divided by 2. 8 times 6.123 times 7.391 divided by 2. I'm going to get, you should have your answer. My area is going to equal 181.02. We'll leave it like that. 181.0 is fine. Okay, you should have your answer here, around here. It would be, do they give me my units? Units squared. Okay, area is always squared. Okay, any questions on this one? All right, let's go ahead and go to the next ones. 11.4, these ones were pretty easy. Looking at my first one, looking at all three, they want us to tell whether the solid is a polyhedron. If so, name it. So looking at the first one, is this a polyhedron, yes or no? No, it has curved sides. So I know that. Is this a polyhedron, yes or no? Yes. And what's the name of this shape? Octagonal what? Pyramid. This is a pyramid, not a prism. Remember, pyramids have a pointy top. You cannot flip them upside down on their base. If you were to flip it, it's going to fall over. Pyramid has that pointy top where all your sides meet at a vertex. So this is an octagonal pyramid. Let's just see if we know how to name the faces, vertices, and edges. So looking at it, if you need to count, go ahead and count. How many faces do I have for an octagonal pyramid? How many? 9. Don't forget to count that bottom one. How many vertices do I have? Vertices are my corners. How many corners where 3 edges meet? How many do I have? 9 as well. And then how many edges do I have? It's a lot to count. Count it carefully. Count it carefully. How many? 16. Okay, let's go ahead and check just to see I counted correctly. Remember the formula was F plus V equals E plus 2. Just checking to make sure we got it correct. 9 plus 9 is going to give me 18. And 16 plus 2 is also going to give me 18. So I'm just checking my work. So yes, this is correct. We did not have to name this, but I want to name it to make sure you guys know how to. All right, and then looking at 12. Is this a polyhedron? Yes. What shape is this? Pentagonal prism. Okay, same thing. How many faces do I have? 7. How many vertices do I have? 10. And how many edges do I have? 15. Okay, that's correct. All right, next question, 14. It says the 2 white congruent circles just fit into the blue circle. What is the area of the blue region? So, formula for area. So we know it. I'm going to write it down. They want me to find the area of the blue region only. Area equals pi r squared. So knowing that, how do I find the area of the blue? I have to first find the area of my big circle. So here's my big circle. I'll highlight it in purple. This is what I'm going to go ahead and find first. So area equals pi. What's my radius for my big circle? 6. Good. This is the radius for my small, which is 3. And if I double it, it gives me my radius for my big one. So I'm going to have 6 squared. Solving that, I'm going to end up getting 36 pi, which is going to give me an area of 113.1. I'm just going to leave it like that. All right, now I'm going to go ahead and find the area of my little circle. Okay, so I'm going to go ahead and highlight my little circle. Keep in mind there are 2 little circles, so I'm going to end up doubling my area in the end. So area of my little circle is going to be pi times my radius squared. I'm going to get 9 pi, and my area is going to equal 28.27. And don't forget I have 2, so I'm going to multiply it times 2. I'm going to end up with 56.54. Now they want me to find the blue area, the blue region. So all I have to do is subtract. Subtracting them, I'm subtracting 113.1 minus 56.54. If I subtract it correctly, your answer is going to be 56.56. And that is your answer for the area of the shaded region. Questions on this? All right, let's go ahead and go to the last question. Looking at the last question, it says, they want you to find the area of each rhombus tile, then find the area of the pattern. This one was pretty easy. It may look confusing because of the pattern, but it shouldn't have been too hard. Looking at it, how do I find the area of a rhombus? My formula for area of a rhombus is either 1/2 diagonal 1 times diagonal 2, or diagonal 1 times diagonal 2 divided by 2. So that's what I'm going to go ahead and use for this one. I'm going to go ahead and take 15 times 7 times 11.4 divided by 2. If I divide it correctly and multiply it, I'm going to get 89.49. And looking at my red one, I'm going to have 18.5 times 6 divided by 2, and that's going to give me 55.5. Now, I'm going to go ahead and count how many reds and how many yellows. So counting my yellows first, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 28, 29, 30, 31, and 32. So I'm going to go ahead and take the area of my yellow triangle. The area for my yellow triangle was 89.49, and I'm going to multiply that times 32. And my area for the total yellow is 2,863.68. And then going ahead and doing that same thing for my red, counting. All right, there are 21 for my red, so same thing. I'm gonna go ahead and take 55.5 times 21. I'm gonna get 1,165.5, and then all you have to do is add both of them. So if you add it correctly, your answer is going to be for the area of 4,029.18 is your answer. Questions, comments, concerns on this review? Okay.